Okay, I'm going to show you how to do a projectile problem that's a little bit more difficult. With this problem, you have to realize that when we're launching this ball and it's traveling 120 meters on a wall that's 22 meters high, they are not saying that that is the full distance. They're not saying that that is the highest point of the flight. So you have to be careful. Unless they say that specifically, it's not. It just happens to be an X and a Y. So I'm thinking probably what this looks like is, if I had to guess, probably right about here, all right, is where the flight is. And so then what we're asking for is right at that point, which is, who knows, it's probably a little bit after it's falling. What's the velocity there? So we're going to have to find an x and a y, as you see, and calculate that instantaneous velocity. They also ask us for the initial speed of the ball, like right to start with, where's that initial speed? And they tell us it's a 25-degree angle. So they give us an x and they give us a y. They just don't tell us what the highest point is. So we can't say, well, v sub y is 0 at 22 meters, because that's not the highest point. All right, so what they're looking for is they're looking for the initial velocity. They're looking at the time that it's going to take to go from this point to this point, the time that it takes there. They're looking for the velocity of the ball right at that point, the tangent point, and so we'll need to find v sub x and v sub y. And is the ball rising or falling at this point? Now, as you've seen, I've drawn a negative v sub y, and so it's falling the way I've drawn it, but I'll go ahead and calculate it and just confirm that. Okay, so I'm going to go to the next page and start solving it, but I know that my x is 120. I know my y is 22, and that is pretty much all I know. I mean, I have an angle of 25 degrees, but I can't say anything about v sub y because it's not 0, it's not the highest point, so I don't know. But those, I'm going to start with the x and the y. And I'm going to go ahead and start solving it. Now you're going to start with two things. This is the best way to solve these problems, is you know your x. You also know that v sub naught times cosine of theta times time is the formula for x. We know that y is v sub naught sine of theta times time plus 1/2 at squared. So we have two formulas. We have two formulas, we have two variables, you know the rest, you basically are going to have to do substitution. There's probably an easier way to do it and a harder way to do it. Whatever way works for you is good. But what I'm going to go ahead and do, and a lot of textbooks or solution guides don't do it this way, they solve everything until the very end, and then they put the variables together and then they plug everything in. I'm going to start plugging in numbers just because I don't want to bring all these variables along. But do realize that sometimes if you take a university physics course somewhere, it's possible they'll say, no, you have to bring all these variables to the end. You can't plug numbers in. And so you'll just do that. But I'm going to go ahead and plug it in. I know x is 120. I know theta. So now what I'm going to do is solve in terms of v sub naught. And I'm just going to tell you that's the easiest way to do it. Again, you could do it the other way. You could solve for time in terms of v sub naught, but do what works for you. So I'm going to go ahead and take 120 divided by cosine of 25, and I'm going to get 132.4. And please, by all means, verify that for yourself. And then I'm going to take that value and I'm going to plug it in here. So I'm going to bring this down here. I'm going to say that y, I know that the height is 22. I'm going to plug this in for v sub naught. Go ahead then and go sine of theta. I guess I should have put 25 in there, but that's all right. It's t. The t's will cancel in that. And we're going to go have 1/2 t squared. Okay, now I'm going to solve for t and just make sure we have our algebra right. What I'm going to do is I'm going to take this quantity and subtract it over. And when I take 132.4 times the sine of 25, I get something like 50 something. I'm going to subtract that over and I'm going to get a negative 33.957. So when I take this quantity right here, which I said is like 55 something, I'm going to subtract it over from 22, so 22 minus that 55 point something, you'll get negative 33.957. And then on this side, I'll hit this. So the next thing I want to do is multiply both sides by 2 and divide both sides by negative 9.8, and then take the square root. And when you do that, you should get time is equal to 2.63 seconds. So please verify that for yourself. There's nothing like experience in doing that. All right, so that's the time that it takes to get to this point in the projectile. If we just go back to v sub naught, right here, we said before that 132.4 divided by that time will be our v sub naught, and so what we find is that that is 50.3 meters per second. That's our initial velocity. So we know a couple of things from this little picture here. We know that the initial velocity is 50.3, 25-degree angle. We know that the time that it takes to get to this spot right here, time, is going to be 2.63 seconds. So we've basically solved part A and part B. Now for part C, we want to know the velocity at this point. And I can't really draw a very good straight line there, but the velocity at that point is going to be a compilation of v sub y and v sub x. So I need to solve for both of those. So v sub x, of course, will be what it always was, which is the sine of theta times cosine, or v sub naught times the cosine of theta. And so I'm going to go 50.3 times the cosine of 25, and I will get 45.6 meters per second. Okay, that's v sub naught, or v sub x. All right, that's v sub x. Now that isn't our velocity because we have to do v sub y. So now I'm going to go ahead and do v sub y, and I guess I'll just go right above here and do it. Run out of room a little bit. And so I'm going to calculate v sub y, and v sub y will equal v sub naught times the sine of theta plus at. Okay, so v sub naught, of course, being 50.3, sine of 25 plus negative 9.8. It's the pumpkin pie. Can you check on it? All right, times 2.63. Okay, so when I do that, I go 50.3 times the sine of 25 plus negative 9.8 times 2.63. I get a v sub y equal to a negative 4.5 meters per second. So it's just coming off the top. So if this was the top of the flight, it's probably actually right about there, not where I drew it. But it's coming down. It is falling, just falling. Okay, so now what are we going to do when I have v sub y and v sub x for that point? I'm going to put them together. I'm going to do the Pythagorean theorem. I'm going to go negative 4.5 squared plus 45.6 squared to take the square root of it, and you're going to get 45.8 meters per second, the instantaneous velocity at that point. The end.